Hello, we welcome here. We welcome you here in the shelter Foo. And now we have a lecture. It's 21st century digital bikes. No gas, no fee or tax, no driver license. What is possible with electric-powered vehicles today and in the near future? Please give a warm hand for Cosmo.
Hey. Thank you and welcome to my talk about 21st century digital bikes. I want to give an introduction in electronic powered vehicles, especially in this wheelless bicycles with an electronic support motor. First, why this talk? It's a report from the make department. This is hands-on hardware. We have to handle screws and stuff with electronics, not classical computer system, digital programming stuff. So this would be a basic journey to this technology and what's different to a normal bike or to classical support motors from older generations. I will also talk about my background to this topic. I have about 1 year experience with this stuff, and so I can give some information further from this new frontier, so not so many people using these tools today. Yes, you see it, there are demo vehicles on the camp, and for sure it's free to ride. Everyone who is interested can have a ride outside on the runway, no problem. The small bike or this tricycle can be tested. We have also some more electronic vehicles on the campsite. Questions, this is at the end of the talk. Who's talking there? I'm Gizmo. I'm fellow geek in the CCC. In real life, I'm working in the IT department, regular computer stuff, network equipment. And yes, since August 2006, there is an interest to this electronic systems on bicycles and motor support for my vehicle to get around. So this means I'm a newbie to this topic. I also just learned this stuff, and I'm not a regular for a decade or so. Why this is my personal revenge, we get on this later. So, how's the talk organized? We have 5 primary topics. First would be an introduction to PWM hub motors. That's the core part of the whole bicycle. PWM is a pulse width modulation. It's eine Pulsweitenmodulation auf Deutsch, so the English and German words are comparable. It's a special technique to drive electronic motors, and this will be about this basic technology. PWM is a general purpose technology, so PWM is built in many motor systems from really small scale and micro-based up to really huge motor systems, so it's not directly connected to this bicycle project. So the second part for sure is PWM on a bicycle. What is the factor, what's the point, what kind of PWM motor do we use on this bicycle stuff? The third thing is connected to this PWM technology, there's a microcontroller in the system. We have a digital controlled system on it, and so yes, you all know what this means. There's some hackability, and I will explain some of the things. The fourth part is the legal situation. Yes, this is a powered vehicle, and every powered vehicle is on a regulation out on the street, on the official streets. So I can tell about the German and the European laws, what you can do on in the public with these vehicles. And at the end, my experience with these 2 bikes, what happened in the last year. So these are the parts. So what is a PWM hub motor? I talked about the microcontroller. It's a small brick from an Atmel system, pre-configured for this computing. The point is we have directly regulated power like an amplifier. It's with a MOSFET field effect transistor inside, and you can have power regulation with this microcontroller. We'll get on this later in detail and show some graphs. It's a generic technology, and so some vendors now build it in a proper size and appropriate way for these bicycles. The point for the motor in connection with this digital controller, it's a brushless DC motor. Brushless means we have only two connectings on the axle. There's no coal brush or stuff like on an old electronic motor, so they're free spinning. I will show it also in a picture later. So this is the motor. Sorry for this picture, it's really bad, but the basic concept is clear. We have a static center, that's the star ring in the middle. This one is statically fixed on the axis inside the wheel, and the ring around is a magnetic ring. This is a permanent earth magnetic ring which is fixed on the turning side, spinning side of the wheel. So this is partly the point where the force is inserted into the wheel. A third thing here is an Hall effect sensor. It's inside. This means the microcontroller. The microcontroller is able to know about the position of the motor, about the rotation situation, and what is the real world turning situation of the motor. This is a picture from a single wheel. You see the hub motor again. This is from the rear side, like on a trike. This one is, there's it opened. This is the open motor. In the middle you can see this the stator, the coil, as a copper coil is statically mounted to the axis, and around this the ring, it's not on the picture, there would be the permanent magnetic ring around this copper coils. Okay, so there is not the classical rotation. Sorry, I have to reorganize this. No, hands-free. Okay, sorry, excuse me. So to the point with pulse width modulation, what does a microcontroller do? It does not accelerate by raising the voltage to the motor. It's on a static voltage, and the acceleration is done by the width of the pulse which is injected into the wheel. You can see this on the red bars. This is just a demo graph. We are not driving with 300 volts, so the numbers are not relevant to this example. The red bars are the pulse width, which is elevated from pulse to pulse to produce this quasi-sinus wave, so you can get this rotation effect and transmit the electronic power into a turning force to power this motor. This is how one phase would look like. Inside the motor there are 3 of these coils twisted in another, and these 3 phases are separated against each other, and with this power inset the wheel is finally spinning. There is a little graph. You can see the 3 coils in yellow, green and purple, and they are scattered. The sine wave and the force line is the resulting force that's powered into the wheel. So this is a basic concept. Now to some better parts. It's interesting parts. The PVM used on a bicycle. So what do we need? Well, for sure, a bike. Every bike, modern bike, should be okay. It's fine what's outside and what's in the mass production. We need the hardware for the driving kit, for the microcontroller, the motor itself, and some other equipment I will talk about. And yes, right, it's an electronic vehicle, so we have the point where we go to the power, and we need accumulators and a battery. For the mobile system, we have no wall plug. So yes, this is always the special part, how to handle these and how much you can do with your PVM motor bicycle. Depends on your battery capacities and stuff. So first to the bike. All standard bikes are good, it's no problem. You can use classical uprights, recumbents, trikes, this one. And also quad systems I've seen, it's no problem. The wheels can be built in to 20-inch wheels up to 28-inch, so you are free to choose where you want to put it on the bicycle. It's also possible to get it a front axis or with a chain connector to bring it in the back wheel and also pedal into the motor. The things that need to get enhanced on classical bikes, like you buy it on a bicycle store, is first thing, you will need better brakes before you build in the motor. Upgrade the brakes, especially if you drive faster than classical 25 kilometers. You really want to enhance these. The cogwheel dimension is relevant because with an upper speed and a higher speed, you need a gear where you still can push force into the pedals. So if the bicycle is too fast and you have already your highest gear, so you just spin in but are not unable to push more power into the bicycle because you are already too fast. So you can play with the cogwheel dimensions and put a really huge gear in, so you can already push at top speed of the motor. Again, with your feet, insert more energy, even at high speeds. If you're driving about 40 kilometers, you would think about suspensions. It's a good point. It's not necessary, but it's a good point because it's really easier that way. So let's see what we need for the bicycle from the PVM stuff. First of all, sure, the hub motor system is necessary. As I told, 20 to 28-inch wheels are no problem. Even smaller wheels are possible, like on a scooter. This is, I think, 15 or 16-inch. And so you also can build it into a scooter system. A gas shift, classical, like on a motorcycle, twist gas shift for your hand grip to accelerate. Pedal assist sensor. This is special thing, Drehsensor auf Deutsch. I will talk about later. It's a recommendation for the legal situation. And for sure, the power controller, which is a black box of the whole system, and the microcontroller. There's everything connected. There are the amplifiers. The controllers here are 20 ampere amplified. And the common voltage range is between 24, that's not true, it's 36, up to 72 volts. So this is a decision, what do you want to do with your batteries? How much battery can you take with you? What is your vehicle? And how many battery packs you want to chain to get on certain voltage. It's sure higher voltage means higher final speed and more torture if you accelerate. So these bikes are driving with 48 voltage. There are 4 12-volt blocks in a chain. This is enough. I want to try 72 and didn't before. We have to cool the amplifiers for this. There's a reverse switch. Yes, the system can drive backward. It's maybe interesting in this track, but not really public use. Optional is to override the pedal assist sensor up to 6 kilometers. That's also a point for the legal stuff in the next chapter. That's what's done with the PWM hardware. This is the scheme. So we have a power source, our central microcontroller, where are also the amplifiers, 2 wires to the hub motor, which are the sensors. These are small signal cables, and the power cord, which is a force cable, more current. And you get the gas shift in the pass. That's the basic scheme. Yes, the power. We need batteries. If anything is better, we would take it, but I think at the moment we will stuck on this and use classical heavy batteries, different technologies. Depends on the prices, I think. Yes, first of all, latest accumulator technology is always a heavy part. If you build vehicles, you know it's always a point of weight. And with these batteries, you fastly have 30 to 40% of the whole bicycle, your batteries. Of the whole bicycle weight are your batteries. These bikes are driven with lead batteries. They are the cheapest, they are affordable. I have always 2 packs to change them against each other and load other while driving the first one. And there's also possible to drive with nickel metal hydride or lithium ion. But this would be much more expensive. Especially lithium ion is this scale with 48 volts and about 7 ampere hours. This would be really expensive and no tests so far. So everything I do here is to chain up 12 volt blocks and with different ampere hours and resulting different weight. So small bicycle has 7 amp hour on board. This tricycle is built about 12 amp hour blocks. This means the small bike has about 9 to 10 kilograms battery in it. The whole bike weighs 20, that's 1/3. And the tricycle has about 14-15 kilo of batteries aboard. That's also half the weight of the whole thing. So batteries would be a nice thing. Let's see what's happening in the next years. Charging hours are also a topic. It's classical regulated charge, so you have 5 to 6 hours reloadings, and so you need more packs to change. We thought about to build in the batteries into the frame, into the whole system, but with this long charge times, that's not a topic, because you cannot change the packs, and the bike would be locked to the power plug if you want to recharge. So we still work with systems where we can take the batteries out of the bike and plug another one in. That's a feature you don't have with electric cars, because they are using 100 or 200 kilograms of axles. No one can lift this on one point day-to-day basis. Here you can do it. That's okay. It's the easiest way. There's an example for the distance which can be managed for this small bike. With 7 amp hours and 48 volt, we can drive about, that's a typo, 30 kilometer distance by 25 km/h. That's a point. That's around. It depends for sure on the topology you drive. It depends how much you drive at top speed, at the best power. That's the best power situation for the motor. The less consumption, the best efficiency. If you use the motor to speed up with its torture, you will burn more echo, more power, and your final distance will go down. You cannot drive so long. With this trike, I do 25 kilometer regularly, and then the 12 amp hours are burned. I knew my track, so I can handle the curves and stuff, and then I'm able to burn it in 25 kilometers in about half an hour. That's really heavy for the accumulators, but it's a solution to get on without gas. So, hackability. Okay, digital controller, any current, so we can do some stuff with it. First of all, is interesting a monitoring system. If you drive blind, well, what I do with this? I have my battery. I have power if it's fully charged, and you feel it gets slower and slower. You have less torture if the battery power goes down. So the first thing would be a monitoring system for voltage and amp during driving, not just in the garage for testing. As I want to build a monitoring system on a local display to see what's going on, and a battery status, which could be drawn by this from this information. Would be the first interesting thing, especially if you want to know when it's finished and you have to push all the lead around with your pedals. So this would be the first. Recuperation is a point which is also interesting and also possible with this microcontroller technology. It means to bring power back into the batteries from the driving situation, which can be two points. If you brake, if you want to brake, you use a special brake switch, and then the motor will do an electronic slowdown. For sure, you cannot use this to brake now as a situation where you need this. It's not possible. You have to do it slowly to use this motor power back and bring it back into the accumulator. The second thing is there is a top speed for these motors, and if you reached on this top speed, you can raise your force, what you pedal into the system, but it would not bring you, make you faster. It will save your power. That's the point. So you have a definitive top speed for this motor, depending on the motor type and the voltage driven. And at this point, if you raise your force into the pedals, then you will save accuracy, not as a rate much more. So that's a way to save energy and to get it more further. We want to build a throttle with these Hall sensors built into the wheel. We are able to know about our actual speed, and 25 kilometer as a limiter would be a nice thing for the legal situation as what we want to do. So we can build larger motors, faster cars to use on campsites like these or anywhere, but are also able to drive out on the streets with this. Steering support is not directly connected to this electronic system for motor power, but I will do this with this track. This will get an RC car I want to build in the steering. Still unknown terror. I talked to people here on the campsite they were interesting recommendations about this. We have some tricks. It should be possible to do some tricks with this pulse width modulation, depending on the torture which is needed or the driving distance at high speeds. It may be possible to do some energy saving by software in aka chip tuning for electronic bikes. It should be possible to have certain states where you can not drive your normal regular PWM like in the default routine. There should be possible to use some tricks to you have some modes to switch between different modes, driving modes, and to use this to save some energy. Anti-block system for the driving wheel would be an idea. The Hall sensor would also tell us if we brake with this wheel that it now freezes, so we can freeze the brake if this is possible. That's all. a situation which we can handle in the microcontroller. And also a very good idea is an immobilizer. If we shortcut the motor, no one wants to drive it. It would be really hard to get it on because a magnetic ring would block against the coil. So we have a type of an immobilizer. No one wants to drive this car away with this harm. So about the legal situation in Germany and EU. This whole thing, what we're doing here is a regulation from 2002. It's an European-based decision, so it's not directly regulated to any German or France, any other countries. It's from the upside, I would say, because I think in Germany no one would come on this idea to allow people these. We have too much regulation, too much licensed staff. But in this situation, it's possible to do this from EU base, and the regulation is what is the first point. Off-road, you can do what you want for sure. It's also possible to think about single admissions, so to build faster bikes, like a scooter, 45 kilometers stuff, and then get an admission for this from a technical instance, certification instance. But I didn't do that at this point. Maybe we want to try, but it would be a long way and would cost money. It's not so good. And there's a Swiss special I will talk about later. First, EU, pedelec. Pedelec is a nice word for it. They just need any topic for this. The regulation says you can have an electronic motor with a force of 250 watt. That's an average force. So you can have peak forces for acceleration which are much higher, about 200 to 400%. So it could be 700 watt at an acceleration situation. But at the average, you only are allowed to drive with 250. The maximum speed would be 25 kilometer. And now that's the point. You need a pedal assist sensor. It's built here in front in the chain wheel, and it's a direction-based rotation sensor, and you have to pedal, and if you pedal first, after that then you can use a gas shift to accelerate. You cannot use a gas shift alone. If it stands here and you push the shift, nothing happens. That's what the regulation says. You have this pedal sensor, if you pedal you can accelerate. With this little trick it was possible to keep it totally license free and without insurance, and that's the point where we're doing this and why we can use it outside on streets without any problems. So like regular bike situation, you even do not need a helmet. It's not a must. You can drive on any streets and use bikeways like a regular bike, which also means in a city or everywhere else you can go on the sidewalk, or drive through the park. It's no problem, just a normal bicycle. There's no sound, it's really silent, and no one will get annoyed about this, even if you have a little bit higher speeds than others in the park. The driver must be 15. I think this is the only extension to the regular biking thing. You have to be 15 to drive this on the street. And the bikes must be roadworthy, like everything, which means lights and reflectors and stuff, for sure. 2 brakes and all this. But if you fulfill these regulations, it's possible to drive 25 kilometers like the old Mofa without any driver license and stuff. It's very, very nice. This is a graph diagram for this power regulation. There are 4 phases. Number 5 is not interesting for us, that's the higher power. There are 4 phases we can drive. The first one is you are allowed to drive up to 6 kilometers with any force. So the motor force, which is the upper arrow, could be about 1 kilowatt or 3 kilowatt. You can really use high torture for this and can drive up to 6 kilometers an hour. At this point, you also can build a switch off to the pass sensor. You don't need the pedal assist sensor up to 6 kilometers. It just must only start to work at this point of 6 kilometers. So this is for challenge people and stuff. They can use a first kick to bring the bicycle to roll, and at the point of 6 kilometers an hour, they have to pedal, not to bring the bike from 0 in a moving situation. And then you can drive up to 25 kilometers an hour with lowering power. So at the point of 6 kmh, you have to lower the power down to the 250 watts. And the dotted line number 4 is this thing with a secondary force where you can have more, and for a short time a little bit more than the 250 if you accelerate it. That's top speed 25 kilometers. The force of the motor will regulate down. And this is also the point where if you now start to really enforce your pedaling, you won't get faster. You will reach 25, 26 kilometers and then just save your batteries. The energy is not used from the batteries or from your pedaling. We'll do this later, you know. The price is just a short round. I don't want to talk about this. It's too much expensive at the moment. This is no mass production. This is not very well known. There are no big vendors, and it's still a niche. And so we have really high investments at the moment. The technology itself is very rudimentary and very simple. It could be much cheaper in a mass production situation. There's no magic. That's just normal simple technology, but still expensive. Besides the batteries, which is another point. Okay. Yes, I talked about single admission. This is hard to achieve because you have to document your vehicle. You have to you have regulations for your wheels. You need larger wheels. You have regulation for brakes. Everything has to be tested. If you do this for one single bicycle, it has a value, I think. I'm totally unable to do any production to get an admission for a series of stuff. So this is far away. That's hard for a company and stuff. And with a single admission, you have still the problem. You have to do it on a country base. You cannot do a single admission at EU base. So if you can get one in Germany with one or the other hack, it does not mean that you can use it in France and stuff. So this is not interesting at the moment. There's one special thing, the Swiss Bee. The Swiss Bee is also a pedelec. It's defined as a pedelec, but it's from a special Swiss company, and they get something like a single admission for the bikes. They can use up to 30 kilometers an hour, which is 5 kilometers faster. And you can use it all over in the EU. I do not know how it worked, but they got the special case. The problem is this vehicle is closed. It's ready, you can drive 30 kilometers, but you're not allowed to hack it. If you hack around with it and change stuff on the controller side or on the motor, you will lose this admission to get on 30 kilometers. So this is a little special from the Swiss. Okay. So what have I done with this stuff? I have these two bicycles. The tadpole trike was my regular driving car to get to work as a commuter, regular basis, 25 kilometer a day, one way, then charge during work, and the way back 25 again. So we'll get up in 3 months, about a little bit more than 3 months, 3,500 kilometers work and back without gas. It worked fine. Nice thing. Rain is always a topic, but everything is okay. The hardware and the stuff works. No water problems, no corrosion or stuff, and also there are very seldom failures on the street. So I never have to give up. I never crashed anywhere on the way. It was always possible to get home. So it's really a nice technology. It worked, and I hope many more people want to join, because I knew a parking lot with about 2,000 cars, every car one person. A parking lot with 2,000 of these, well, maybe. So the power controller project is still a theory, which I want to enhance on this campsite. So I can talk about experience, but this is still already the next thing. And the street experience. Again, this is the bike with a windshield, just for completion. You see it here in real life. The windshield is homegrown. We tried out some stuff. Some technical information about the system, the motor systems, so from a company called Crystalite. It's a Canadian-based company, but sure they're built in China. It's a 45 kilometer top speed, and I had about 0.7 kilowatt, or shortly 1 kV. That's really enough for such a light vehicle. I have 4 12-volt blocks, chained 48, and as I told, 25 kilometer per charge, with full throttle. So if you drive smoother and use more pedaling, you can reach 35 to 40 kilometer with this trike. It's no problem. These 25 kilometer is really hard driven by using the motor all the time. As I told at the beginning, the important point are brakes, very important point. So this bike got oil disc brakes. They're very smooth, like on a motorcycle. You got 2 of these, and with this axis you have really a good brake condition if you go in. The wheels had to be hardened because with the normal one at this top speed of 45 kilometers they broke down. The spokes are too thin, and the rim was flaky. So we got an 8, and now it's hardened stuff from the BMX scene. They have 20-inch wheels and much harder profiled rims and spokes. And the steering is something special for the trike. You have a whole steering system on the side, which you have to harden because the hits from the wheels are really rough, and at some point we have problems with the steering heads. That's a city, it's a city bike, the small edition, a funny little folding bike, 20-inch wheels and a front motor. And this one is a legal one. It does not drive 25 kilometers an hour. Regular basis with a pass sensor and 7 amp hour batteries on the switches. So with this, 40 kilometer per charge is possible. If you pedal even more, in the city it's for sure less, because you have too often situations where you use it to accelerate. Battery mount was the biggest problem, and is still. You see it looks really ugly. It's 10 kilograms. It's 1/3 of the whole bike, and with bumps and stuff we always have problems with screws and some mounting kit. We want to take it in backs, left and the right. It's not a good solution to put it on the top of the backpack. The funny part is full suspension. In Berlin you will need this. Even in other places. Here on the field it's also very, very good. And the V-brakes, again the brakes, yes, they were these crappy old ones, and now we had some big brake solutions to enhance this. So, yes, bikeway is the best thing for it. You have no problem with car drivers, it's the easiest way. On roads, be careful. It's a really new situation that you are such fast with the bike. I knew that everyone can pedal the speeds with a regular bicycle, even if it's especially if it's a light one. But with this motor, you are able to do this every time, and we use much more acceleration moments. If I have one of these hardcore bikers beside of me, this guy is really tough, but sorry, it's an electronic motor, and the first torture is really, really high. No chance. At the top speed he will kill me, but not for long. So be careful with the food chain. These cars and all other people do not know about your power. They do not know that you can hit the grip shift and give some power and force you. So be careful. Always think in this passive driving, you know. The pigs, no problem. No one recognized me at this point. We have no police contact at all. I do not know if any policeman is outside there knowing about pedelec. And I also don't want to tell one if he asks me the word pedelec. I know his reaction. Totally, what? It's unknown. They do not know it, and they just don't ask because it makes no sound. It's totally silent, and so I really was near to them, no interest. Okay? So maybe we will have some reports from this. At this moment, no contact with the police. Yes. And the commuting, finally, the commuting thing was about 1,000 kilometer a month. And oil. Damit's nicht quietscht. Danke. Okay, for the final one, good thing from the last Congress, I want to bring it here to the end.
Are there any questions?
Okay, so now we have some time left to do question and answer here, if you want.
Yeah, I wonder about the city bike. If you turn off the electronic stuff, does you need more energy to push it, or will it be like a little brake? Or
sorry, again, pardon.
If you turn off the electricity, the city bike has a common chain.
Yes,
power.
Sure. So you need this for the pedaling part, yeah. So you can drive it without the batteries. The best thing is to load down the battery, to bring away the batteries, so you do not need to drive this weight. And then, yes, you feel a force against you. It's harder to drive this wheel. So it's harder. The wheel itself weighs about 6 to 7 kilograms. So you have this weight on board, and you have to push into the magnetic ring, but only in the weight, not in a magnetic force against you. It's just about the weight stuff. Another thing is it rolls really easy. If you got it on a speed, it keeps on rolling, so it's okay. It's not the point.
Hello. Did you ever calculate the running costs for the energy per kilometer?
Yes, but I stopped it. It's too cheap. This 25 kilometers thing cost me 0.6 kilowatt hours. 0.6, so a little bit more than a half kilowatt hour. One I charge at home, that's expensive power electricity. One I charge at a company with laser cutting systems. Say not interested in my kilowatt hours. So I stopped with it at cents, 100 kilometers for cents. Yes, works.
I've got a question as well. With these pedelecs, you put a lot of money and weight onto a bicycle. So, in the end, what's the point? What's the big advantage?
My personal revenge. Yes. Okay. That was on the first slides. What's my background? Yes, it's my personal revenge. I want to drive to work 5 days a week. I did it with a normal bicycle, 25 kilometers one way and 25 kilometers back way. It's really easy, sun and it's good weather. But in the end, it's Monday to Friday. It's early in the morning and after work afternoon. So for sure, I want an easy way to drive. They cut off my driver license. For sure, you can do it 5 days a week, and you could do it for weeks and weeks and weeks. And with normal biking, no, it's winter at one point in the year, and yes, sure, but for the force, I'm a nerd, I'm a computer geek, man, so it's really not a training stuff. And for 5 days a week, I need this. That was the point why I started and why it's really working for these. So this is the point where we can use it really, and it worked for me. That's what I mean.
I have a question. I expect this is an asynchronous motor machine. Is it possible to use this machine in generator mode for if you go in downhill to use it as a generator to load up the battery again?
Yes, that's possible. This is a point with a special brake shift, which you can use on a topology where you can roll down the hill and bring some energy back, but it's only a few percentage. It's not so much with these light vehicles. So it would cost much more extra. It's very pricey. I'm not sure about it. I didn't try it at the moment. But I think it's a point for heavier vehicles, larger stuff.
But you can use it as an electrical brake, at least for slow braking,
yes.
Not for hard braking. They're
yes.
using disc brakes, of course. Another thing is, what's about a hybrid mode that you're just eliminating the chain and using a generator at the front and using the whole system only with electrical power?
That would be. Do you mean that you only pedal into a dynamo? That you only pedal into a dynamo system and then use only the current? The problem is even this bicycle, this pedelec situation. For the technical side, it would be really nice. I think we will do this. There are these gearboxes at the moment. It would be possible to take one of these new gearboxes where your pedals are connected and directly have a dynamo on this gearbox. So we will rip off the whole chain stuff and just have this gearbox system in front. I'm not sure if this is legal.
Okay, thanks.
With this dynamo, the chain, direct chain is the effect one. Yes, you get this pedal here. Angle. Yes.
I don't have a question, but I can give some addition on experience. I have got the Mercedes hybrid bike. I think it's one of the first electrical commercial bikes available.
Yes, in mid-90s.
Yeah, I've been driving it for about 5 years or so, and I had one police experience. As you said, you had none. I was driving without light on the sidewalk, I have to admit, and the police car stopped me, and I got, possibly I should have switched on the light. But he didn't want anything. He just wanted to ask, what is this? I have never seen such a bike before.
Oh, okay.
How long does it go? And then he went away.
Okay, but they were not interested in any
They were not interested in me
so.
driving without the light, driving on the sidewalks. He just was interested. And that was in Bavaria. It was the only positive experience with the police.
Okay. I did this in Bavaria too.
The other thing, adding on the question previously, I think the main advantage of these bikes is if you go uphill or something like this, then this is really easy. driving a long hill with a normal bike just annoys me. I don't like it. But with this electrical bike, it's about the same as driving downhill or in the street. So it's really, if you have a hill on your way to work or back or whatever, that really makes it easier. You don't sweat anything. You just drive on, hill up, hill down, no problem. Yeah, you have to use the pedals, but you don't need real force. You really feel it's like a form of giving the acceleration, but it's not. You don't need really power to get forward
yes,
or get up or get
point.
down. Except if you want to go fast, of course.
Yes, right. This pedal assist sensor is just a switch. If you pedal, it's okay. It does not recognize how much force you put into the pedals. You have just easily dee, and then you can give fire. Just plug it. You build. The thing is, we build the sensor on the bike and then disconnect. That's the way. So the controller gives free, sure, and so yes, that's the actual situation.
I mean, I never used such an electric bike, but I think pedaling is also important to give a stabilization for the bike. At least for a bike, not for a trike. I don't know on a trike, but on a bike, pedaling is absolutely important for the stability of the driver. That's at least when you get to certain speed, then the movement, the constant movement of the legs, is giving stability to the street position.
Not so much. You can hold at 5 kilometers an hour. You can hold it. It wouldn't tip over. Is someone left?
If you want to exceed the 25 kilometer limit.
Sorry, I don't understand you anymore.
Okay. If you want to exceed the 25 kilometer limit, what kind of admission would you need then? Is it a motorcycle then, or is it a motorbike? Or
yes, that would be the part you have to admit it in one or other way. Street admission, if you want to go faster.
Yeah.
Yes, that's the point where you need to see street admissions. And in a single situation, you won't do that. With one crafted bike, the single admission is really hard.
Okay.
But then it's possible. 45. The next thing would be a scooter, 50 cubic centimeter class, 45 kilometer officially, but would be hard.
Okay. Thank you.
Okay, I think the rest of the questions, or if you want to have a ride, we can meet outside and just talk away. Thank you all.